if you have a piece of graph paper, let's take a look at a composition of reflecting over the y equals x as well as x. I want you to see what happens with that one. So if we're going to write this, y equals x composed with a reflection over the x-axis. So that composition. And what we could do is we could make it, I don't know, we could use the original. We could use the points that they give us. I think if we have a quadrilateral, it'd be easier to see what happens than if we use a triangle, because the triangles don't always have the right look to them. So in this case here, which has to get done first? Going over that or that line? Yeah. So we have to go and perform this first, because that follows other way around. So if we, the reflection over y equals x is following reflection over x. So what we have to do is we have to take a matrix, we have to multiply it by, let's see, 0, 1, 1, 0. What's that? Oh, yeah, what am I doing? I'm not looking at the right. Where's the, yeah, let me write up here, 1, negative 1, 0. 1, 0, 0, negative 1. Okay, so that matrix first. So then we have to reflect this polygon. And then we're going to take the result of that. And then we've got to reflect it over y equals x. So I'm going to pull it off of here. It's going to be 1, 0 for the first point, 4, 1 for the second point, 6, negative 2, and then 3, negative 5. So this is the reflection over the x. And if you want to graph these, you can. You can also look at the graph that shows up on page 264. If you want to expedite this, make it move a little faster, you're welcome to take a look at that. But let's go through the matrix multiplication. Do you want to do it on the calculator or you want to do it on paper? Paper? Okay. Are we out at 9:05? Gosh, the world's going to change this week. Not going to be the way it is in writing. So if we take 1, 0, and we multiply it all the way across, what's the top row going to be? It's going to be the same. And if we take 0, negative 1, and we multiply it across, what happens to the bottom row?
They're opposites.
They all become opposites. So 0, negative 1, 2, and 5. So now we need to take that resulting matrix and multiply it by y equals x. But we can't take this and multiply it by the 2 by 2. We have to put the 2 by 2 in front of this. So So now what's gonna happen to the values when we take the y equals x? They get switched, don't they? Yeah, so 0 gets multiplied by the top value and 1 multiplied by the bottom value, and they get added. So we're essentially just taking the bottom row and putting it on the top. So these can go pretty fast. And then we're taking the top row and we're putting it on the bottom. So this is the resulting matrix right here. That comes from the composition of reflecting over the x following the reflection of y equals x following the reflection of over x. So how do you get to that in one step? That's the big question here. How can we do the whole thing in just one matrix multiplication? Combine these two and get 1, 1 and 1, negative 1? Well, let's see, if you did 1, 1, like the top, if you called that if you did a 1, 1, 1, negative 1, then you'd be taking and multiplying by both the x and the y and adding them together. You get much bigger numbers. So I don't think that's going to work. You know, if you look at these two, don't the 1 and the 0 just switch? But then here, see, the 0 is misleading because the 0 doesn't have a positive or negative value to it. But here, the 4 and the 1 switch, but the 1 changes its sign. And then the 6 and the negative 2 switch, but the negative 2 changes its sign. So we're changing the sign when we move this to the top. And we can also see that the absolute values are being switched. So if we were to use the 0, 1, 1, 0, that's close. But what's missing is, yeah, so when we end up with our x values, they need to come up being negative. And our x values come from the first row. So if we can make that a negative 1, we just did it. So now take a look in the book. Look at the red quadrilateral as it becomes the, I didn't do the one in the book. I did it differently. Okay. That's all right. We got to stick with this one. So if we take this matrix here, so this is the pre-image, and then it becomes the image of the composition here. We need to look at what that looks like. But you can't follow the book because I took the wrong colored matrix. But I can do this. 1, 0. 4, negative 1. And then 6, 2. And then 3, 5. so that's what we started with. And then what we end with is this one here. So we have 0, 1, negative 1, 4, 2, 6, and 5, 3. This is not pretty.
You didn't put down the pre-image, you put down the result of,
No. That was the pre-image.
but I don't think that's, you did 4, negative 1, didn't you? Not 4, 1.
So 0, 1 is A prime. Negative 1, 4 is B prime.
It's 1, 0, so the top is up.
This is the black one's the pre-image.
Oh, okay.
Oh, I did 4, negative 1. Is that what you just said? Yeah. It's gotta be 4, 1. And then C's gotta be 6. Oh, shoot, yeah. 6, negative 2. Okay. So then we go from A to B to C, and then 3, negative 5. There's D. Okay. Is that better? That's the original image. That's the pre-image. And then it becomes A, which is 0, 1. B, which is negative 1, 4. C prime, which is 2, 6. And D prime, which is 5, 3. There we go. Orientation preserved. A, B, C, D. A, B, C, D prime. So this whole thing gets turned how many degrees? How far did it get rotated?
9.
Are you guessing?
Yeah.
Yeah. It's 90, and here's, if you look at this point from A to A prime, if you look at it, this point starts on the x-axis and it ends on the y-axis, and they form a 90-degree angle. This point B starts 1 above the x-axis and it ends up 1 to the left of the y-axis, so that ends up being a 90-degree turn also. If you look at from D to D prime, here's the point D, there's D prime, that's a 90-degree angle. From C to C prime, that's a 90. From B to B prime, let's see, here's B to B prime. Those are all 90-degree angles. So this ends up being a rotation of 90 degrees. That's what the composition of these two are. So if you look at, this is the x-axis, and then you had your y equals x line, the angle between the x-axis and the y equals x line is 45 degrees. And in geometry, we learned that when we reflected points over two intersecting lines, that we doubled the angle between those two lines to come up with what the rotation was. Do you remember? You know, it was one of those kind of fringe lessons about this time of year. So, I don't know, I don't think I got through this as cleanly as I wanted to. And I think what makes most sense shoot, this one, I don't know. I see you right away tomorrow morning, right? Yeah, so that's a good thing. Hang on, don't run away from me, okay? Do this. The assignment that I give to you, limit yourself to no more than 25 minutes. Put 25 minutes of time into it. And then we will continue working on it when you come back tomorrow morning, okay? And this is the assignment, though. I did not take it out of the book. This is a tool. No, it's not a real tool. So they were only sitting on the table right behind you. And there's a kid up here. So just this table, there were three of them sitting there, and then one girl was here. That's all we have. Thank you.
Had to make sure the recycling bin was at the not recording. Oh, yeah. He said it was fun.
Oh, and you know it.
He has it.
Oh, sorry. Oh, that's right. I forgot to turn it off. That's okay. I don't know that anybody creeps on us.